Jai Hind everyone. I am Vivek Kumar Pansari, Assistant Professor in Department of Mechanical Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. Okay. So, in the lecture series of engineering mechanics, the topic which I was covering, that is the shear force and bending moment. So, many things related to the basic concepts, how the shear force and bending diagram will be drawn, all these things has been already covered in the particular videos which I recorded earlier and in my live lectures. Okay, so all these you can find the link of the playlist in my description of today's video, so you can go through these. Okay, so in today's lecture I am covering the part problem solving. Some problem I had already taken in my previous live lecture, but some of my students asked me, sir, please share one more problem so that the concept will be quite clear. So, I hope after today's lecture the things will be more clear to each and everyone, and you will be able to perform the question of shear force and bending moment definitely in your exam. Okay? So, each and every point, what are the basic things required, that will be covered. I am considering in this lecture you are knowing what is basically the shear force and bending moment. I am not going in much detail of these, how to find out the shear force and bending moment. Okay. It is the algebraic sum of all the forces, it is the algebraic sum of all the moments, sign convention, it is known to you. What will be the shape of shear force and bending moment diagram, that is known to you. In which case it will be a constant line, in which case it will be a inclined line, in which case it will be a quadratic curve, parabolic curve, in which case it is a cubic curve. So, all these things I have covered. What is the purpose? So, I am directly coming to the question solving part. Okay. Okay, let me reach to that point. Okay, these problems I already covered, these problems already done. Okay, I am not going with these. This problem already done. Okay, in my last lecture, this is solved. Okay, so you can go through. Now I am coming to one problem. Okay, so let me start the question. I am drawing a beam. I am trying to cover maximum things today. Okay. So, definitely, sorry, these are the two supports. A overhanging beam is there which is subjected to UVL, and the intensity of UVL is, the maximum intensity of UVL is 40 kilonewton per meter. Okay. The length is 3 meters. In between this there is one more force, that is the force of 80 kilonewton. Okay, this distance is 1.5 meters, this distance is 1.5 meters. I hope the things are visible, and at the end of this the load is 20 kilonewton. Okay, load is 20 kilonewton, and this distance is also 1.5 meters. Let me give the names to these points: A, B, this is C, this is D, and this point is E. So, I hope this is the sufficient question for exam point of view. Overhanging beam is there, it is subjected to UVL, UVL is there, point loads are there, and number of sections are required are more than 2. So, students, please साथ में solve करिएगा, those who are available in the lecture. Okay, so those who are available in lecture, they can write at least Jai Hind and anything, so that I may know ki who all are present here. Okay, so let's start. Okay, so what is the first step? Okay, this is the place I am leaving to the shear force and bending moment diagram. So here I will be solving the question. Okay, what is the first step? The first step is to find out the support reaction. First step is to find out the support reaction, and for finding out support reaction, what we are doing, sigma Fy equal to 0 I am putting, and there are two supports. At A there is support reaction RA, at D there is a support reaction RD. Okay, so what can I write? I can write RA plus RD, these are the two upward forces, then minus downward force of the UBL, this will be equal to the area of the triangle, so half into 3 into 40, then point load at C, that is minus 80, and the point load at E, this is minus 20, it is equal to 0. So what it is coming out? It is coming out RA plus RD, and the total sum of this, it is minus 160 equals to 0. So I can say this is the equation number 1. Here there are two unknowns are there, so obviously one more equation is required. So one more equation I am writing towards point A, sigma MA equal to 0. It means the algebraic sum of all the moments about point A equals to 0. This is well known. I am not putting much focus on this because we are knowing, जानते हैं हम support reaction निकालना, पहले lectures हो चुके हैं. So what it is? Okay, now I am writing RA की वजह से moment about point A, it will be 0, and due to RD, how much it will be? RD into 6. Okay, then I am considering the UBL, the load of UBL is half into 3 into 40. How far it is from point A? So obviously this is the bearing load, it will be at 2L by 3 distance from point A. So here I am writing 2L by 3, it means 2 into 3 by 3. Then another load which I am considering, that is 80, the distance of 80 from point A, it is minus 80 into what? 80 into 4.5, then minus 20 into how much it is? 7.5 equals to 0. Okay, so these are the two equations, RA plus RD minus 160 equals to 0. This is the equation number 1, and the second equation is RD into 6 minus half into 3 into 40 into 2 into 3 by 3, that is the distance, minus 80 into 4.5 and minus 20 into 7.5. By solving these two equations, you will be able to find out what? You will be able to find out RA and RD. Please निकालिए. Students, those who are available in the class, please find out RA and RD quickly. 30 seconds I am giving to you. Two equations are available with you. Okay, so please. आप सॉल्व करेंगे because ultimately you have to do the question. So what is RA plus RA and RD? How much it is coming? Anyone is solving? Anyone? Please. According to me, आप लोग नहीं लिख रहे हैं, तो now I have to write RD is coming out 105 kilonewton and RA is obviously 55 kilonewton. Please match your answer. Please check. Is it correct or not? Your answers must be matching. Okay, RA plus RD. RA और RD निकाल दिए मैंने. RD 105, RA 55. Okay, let it be. Okay, now this is the support reaction. If you are doing up to this point correctly, then out of 10 you will be getting around 2 and 2.5 marks. Okay, so this is the, बिल्कुल आज एग्जाम पॉइंट ऑफ व्यू से ही बात कर रहा हूं मैं completely. Now for drawing the shear force and bending moment diagram and for analyzing this particular beam, what I need to do? Now I need to do the sectioning of this beam. So how many sections are required? बहुत बच्चे पूछते हैं कि सर कितने सेक्शन, आप कैसे डिसाइड करते हैं कि कितने सेक्शंस डालने हैं? Okay, nothing. जहां जहां चेंज हो रहा है, wherever you are finding any change from A to B, there is a constant slope variation, so there must be one section here. From B to C, the condition is same, so in between B to C, there must be one section. At C, the scene is changing, so from C to D, there must be one section. at D, because of the support reaction, the scene is changing. So there must be one more section at between D to E. So obviously कितना A से B के बीच में एक, B से C के बीच में एक, C से D के बीच में एक section, and from D to E there must be one section. Okay, so 1, 2, 3, 4 sections are required. So lengthy question. So please cooperate with me. Solve करें साथ साथ. Now I am taking the section plane. Okay, section plane. I am giving the name section 1, 1. Okay, और थोड़ा सा आप लोगों के हिसाब से मैं इनको x1 x2 लिख देता हूं. हालांकि x1 x2 लिखना नहीं चाहिए. It must be x, but 1 से related है. That's why x1, nothing else. Otherwise, it is the variation with the length, with the x. Okay, so x1. Now here आप लिखेंगे 1, 1. सेक्शन 1, 1 को सॉल्व कर रहे हैं. नाउ कम टू द पॉइंट. मेन अवर इंटरेस्ट क्या है? द मेन इंटरेस्ट इज टू फाइंड आउट shear force and bending moment. So shear force at section 1, 1. The basic definition of shear force, for finding out shear force, it is the algebraic sum of all the forces acting either side of the section plane. So the section plane 1, 1, it is dividing the beam in two parts. One, the left section of the beam, another one is the right section. So I am considering the left side of the section plane, and algebraic sum I am taking. Algebraic sum I am taking. So what are the forces? This. So shear force at section 1. There are two forces I am observing. One is the RA, which is 55. It is positive because it is on the left side of the section plane and upward. So 55 positive. And what I am considering here? I am observing that this much of UVL is also there. x1 is the distance. y मैंने मान लिया इसको, यहाँ पर जो है हमारा इसको y मान लिया. ट्राइंगल को जहाँ पर कट कर रहा है इसको मैंने y ले लिया. So this much of UVL कहाँ से कहाँ तक? From A to x1. And negative, why it is negative? Very clear, because it is on the left side of the section plane and downward. So 55 minus this. Now I have to find out the load because of this triangle, which is of x1 base and y. So y will be how much? Y कितना होगा? By applying the similar triangle properties. Similar triangle of what? Two similar triangles are there. What are the two similar triangles? Let me draw here. One is this. Another one is here. It is 3 meters, and how much it is? It is 40. So how much will be the y? By comparing these two, x1, y, 3 and 40 kilonewton per meter. So I can write y upon x1 equals to 40 upon 3. So y will be how much? Y will be y equal to 40 x1 by 3. And for this triangular load, इस UVL के लिए क्या लेना होगा? मुझे इस triangle का area. So what can I write here now? I can write 55 minus half into x1, और y कितना आया भाई similar triangle से? Y is coming out 40 x1 by 3. Is it okay? Is it clear? I hope it is clear. 40 x1 by 3. कैसे आया ये? By comparing these two triangles. These are the similar triangles. So y upon x1 equal to 40 upon 3. Clear? चाहे एक प्रॉब्लम हो आज, बट कंप्लीट करेंगे, पूरी करेंगे, so that सभी को क्लियर हो, कोई कंफ्यूजन ना रह जाए. Okay, so I hope this equation is clear. Now, from which point to which point this equation is valid? From which point? From A to B. So now I am putting the value. So at x1 equals to 0. At x1 equals to 0. x1 equals to 0 मतलब at point A. At point A, how much will be the shear force? This term is going to be 0. So it is 55 kilonewton. Positive होगा? Yes, it will be positive. And at B, for B, B के लिए क्या वैल्यू होगी? B के लिए x1 equals to 3 meters. From the diagram, beam को देख सकते हैं, beam को देख सकते हैं easily. Okay, so put the 3 here. 3 आपने यहाँ रखा, 3 से 3 cancel हुआ. This is what it is coming, 3 by 2, so 20, 60. जरा कैलकुलेट करके बताएं मुझे कितना आ रहा है. I have done the calculation. I made it. मेरे दिमाग में तो हो गया. Please, but students, those who are in the class, please do the calculation. at x1 equal to 3. Put x1 equal to 3 in this. What is the answer coming out? आप participate करेंगे so it will be better for you. एग्जाम में पंसारी सर नहीं करने वाले क्वेश्चन. Yes, please. What is coming out? 3 3 कैंसिल हुआ, 1 3 हुआ, 23 60 मेरे हिसाब से आ गया. At B it is minus 5 kilonewton. So these are the two values which are coming out for shear force from the section 1. I hope itna point clear hai. Okay. Now may I move ahead? May I move ahead for the next one? Okay. Bending moment likheं. Okay. Let me come to the bending moment. पीछे चलेंगे अभी जब ड्रॉ करेंगे उसे तो चलेंगे पीछे. Bending moment equation. Bending moment where? At section 1 1. Okay, so let me divide this in two parts so it will be easier for me. Okay, bending moment at x1. What is bending moment? It is the algebraic sum of all the moments acting either side of the section plane. Okay, section plane के left side में we are considering two forces. We are observing two forces. One is 55 and another one is the UVL of half into x1 into 40 x1 by 3 intensity. तो यदि दो लोड हैं तो obviously there must be two moments. So moment due to 55 about section 1 1. So 55 it is x1 distance पर है. So 55 into x1 and how it will be? The tendency of rotation will be clockwise. Tendency of rotation will be clockwise. So on the left side, if the clockwise tendency of rotation is there, then definitely it will be considered as positive. So 55 into x1. What is the other load? The other load is this. तो पहले मैं load लिखे लेता हूं यहां पर. What I am writing here, half into x1 into 40 x1 by 3. 40 x1 by 3. This is the load. What is the distance of this load from? What is the distance of this load from section plane? तो मैंने इतने लोड को कंसीडर किया. This much जो मैं अपने पेन से यहाँ शो कर रहा हूं. कहां पर होगा? Obviously 2 by 3 distance. Distance कितना है यहाँ पर? Distance is x1. So it will be at 2x1 by 3 distance from point A. So what will be the distance of this load from section plane? If x1 is the total distance and from A it is 2x1 by 3. So obviously from the section plane it will be x1 by 3. So I am writing here the distance is x1 by 3. And what will be the nature of rotation? This is the load downward, so it is anti-clockwise, and on the left side anti-clockwise is considered as negative. So I hope this is also clear. Half into x1 into 40 x1 by 3 into x1 by 3. Is there any doubt? Anyone? किसी को भी कोई डाउट है चैट बॉक्स में जरूर लिखें प्लीज. और यदि डाउट नहीं है तो then we are moving ahead. Okay, this section is valid from A to B. So at x1 equal to 0, x1 equal to 0, everything will become 0. x1 equal to 3, these are known to me. So MB कितना आएगा भाई? Just put the x1 equal to 3 here. देख लीजिए. A के लिए x1 0, B के लिए x1 is 3. Okay, so put the value 3 here. How much it is coming out? Please निकाल दें जरा जल्दी से. Quickly. How much it is? MB. How much it is coming out? जैसे ही आप इसमें x1 equal to 3 रखेंगे, I hope it is coming out 105 kilonewton meter. So the first section is done. The first section is done. Is it okay? Now I am reaching to the section 2. Section 2 कहाँ आएगा भाई? I have already told that section 2 will be here. सेक्शन 2. मैं इसको सिर्फ नाम के लिए x2 लिख रहा हूं, फिर से स्पेसिफाई कर रहा हूं क्योंकि ये सेक्शन 2 से रिलेटेड है. अदरवाइज इट इज x. ओके, नथिंग. तो इसको कंफ्यूज मत होइएगा. ओके, नाउ आई एम राइटिंग द शियर फोर्स एंड बेंडिंग मोमेंट इक्वेशन फॉर सेक्शन 2. definition and the method is same. It is the algebraic sum of all the forces acting either side of the section plane. अगेन एंड अगेन रिपीट करना जरूरी होता है, ये तभी याद होता है. तो इस सेक्शन 2 के on the left side what are the forces? One is the support reaction, another one is the complete UBL. Now the complete UBL is on the left side of the section plane, so and the support reaction. So what can I write? I can write here section 2 to shear force at section 2, it will be 55 minus half into 3 into 40. ठीक है ना? Sign convention is known to me. Left side upward is positive, downward is negative, and on the left side of the section 2 there are two forces. One is the support reaction, another one is the triangular load. So there are two. Okay. So 55 into this. Okay. Shear force at section 2, how much it is coming out? It is coming out minus 5 kilonewton. Does it depend on this? Okay. क्या ये इस पे डिपेंड करेगा? क्या इक्वेशन इज कैसी है? इक्वेशन इज कांस्टेंट लाइन इक्वेशन. सो इज इट डिपेंडिंग ऑन दी एक्स? नो. सो from B to C, the shear force will remain constant. Yes. So at B, shear force at B will be minus 5 kilonewton, and shear force at C, this will also be minus 5 kilonewton. And on this point C, we are observing that there is one point load. So on the wherever in the beam we are finding any point load, then क्या होता है? उसके left and right side में we are getting two different values. So what can I write here? I can write shear force at C on the just left side. Why I am writing left side? Because my section plane is on the left side of the section plane. लेफ्ट साइड ऑफ द पॉइंट सी. तो ये जो हमारी सेक्शन 2 की इक्वेशन होगी, ये हमें क्या देगी? लेफ्ट साइड की वैल्यू सेक्शन सी पर shear फोर्स की. ओके. सो दिस इज क्लियर. एस बी एंड एस सी. एस बी इज minus 5 kilonewton and SC is also minus 5 kilonewton because it is not depending on what? It is not depending on the x. So it is constant. And on the left side, क्योंकि point load पर I am telling you at point C there is a point load, so on the left and right side we will be getting two different values. Now write the at B and C. Let me write here at B and C. Now I am writing the bending moment equation. Bending moment equation, algebraic sum of all the moments acting either side of the section plane, and how many loads are there? There are two loads, 55 and minus half into 3 into 40, which is the UBL. So 55 किस सेक्शन पर बात कर रहे हैं? We are talking about the section plane 2. So 55, how far it is? It is at x2 distance and the tendency of rotation is clockwise. So it is 55 into x2 minus, let me write the load. Load is half into 3 into 40. And how far it is? How far it is? Half into 3 into 40. कहाँ पर होगा? Half into 3 into 40. Let me use this. Half into 3 into 40. यहाँ पर कहाँ पर होता है ये? Where it is? Obviously from this point it should be at 2 into 3 by 3. Okay? From 2 into 3 by 3. तो ये जो load है half into 3 into 40 का, from point A it is at distance 2 into 3 by 3. So what will be the distance between half into 3 into 40 when it is represented by one single point load and section plane? So it must be x2 minus 2 into 3 by 3. Please check कर लें एक बार, यही होगी या नहीं? मैंने बिल्कुल अभी आपको एक्सप्लेन किया यहां पर, ठीक है ना? Okay, this equation is valid from B to C, and for point B the x2 is 3 and for point C x2 is 4.5. So at B, x2 equal to 3, वैल्यू पुट करें, आंसर निकालें. प्लीज फाइंड आउट द आंसर. Please find out the answer what you are getting from this equation of bending moment. mx2 equal to 55 into x2 minus half into 3 into 40, x2 minus 2 into 3 by 3. What you are getting here? I hope the same value you will be getting. 105 kilonewton meter. 105 kilonewton meter. And for point C, x2 equals to how much? It is 4.5 meters. जरा रख के देखिए भाई, what it is coming out. Please आंसर बताएं, साथ साथ आंसर बताएंगे तो I will be feeling much comfortable that you people are getting. सिर्फ वैल्यू ही तो रखनी है. x2 equal to 4.5, nothing else. No. चलिए कोई बात नहीं. May I write the answer or anyone is writing? It is coming out 97.5 kilonewton meter. Okay, 97.5 kilonewton meter. अभी shear force bending moment diagram का shape भी बताऊंगा, curve भी बताऊंगा कि how it is coming. Okay, don't worry. पहले calculation कर लें, then we will be drawing the shear force and bending moment diagram. Okay, clear? Now I am coming to another section, and it will be in between C and D, and the distance from A will be x3, distance from here. Okay, definition wise it is clear. Algebraic sum of all the forces acting either side of the section plane. What are the forces on the left side of this section plane? RA, UBL completely, and AT. So I am writing here section 3, shear force at section 3, 55, sorry, okay, what it is? 55 minus half into 3 into 40 and minus 80. These are the three forces on the left side of the section 3. Okay. How is this equation? इसको तो सॉल्व कर ही सकते हैं एटलीस्ट. 60, 80, 140 हो गया. 140 minus 55, how much it is coming out? How much it is coming out? Please write the answer. Minus 85 kilonewton. Is this equation depending on x? No. So shear force between what? Shear force between C to D will remain constant. And this equation is valid from where? From the right of the C to just left of D. So I am writing here shear force at C, from this equation it is minus 85 kilonewton, and shear force at D is also minus 85 kilonewton. And as I told earlier that wherever we are finding any point load in the beam, so here at point C there is one point load, so on the left and right side we will be getting two different values of shear force, and similarly at point D there is a support reaction which is also acting as a point load. So D point के भी left and right side में we will be getting two different values of shear force. So one value of shear force at C already available, minus 5, and now this section plane 3 is the right side of the C. So मैं यहाँ पर लिख दूंगा what? It is on the right side, and for the D the section plane is on the left side. So D point के लिए what I am writing? Just left. Okay, now I am coming to the bending moment. Bending moment equation. बहुत आसान रहता है bending moment equation लिखना, because how many loads are there? There are 3 loads on the left side of the section plane 3. So 3 moment components will be there, and it will be 55 into x3 minus half into 3 into 40, This is the load I am writing, and how far it will be? It will be at x3 minus 2L by 3. Already explained this thing. Okay, यहाँ पर बता चुका हूँ, हाफ इंटू 3 इंटू 40, ए पॉइंट से 2L by 3, 2 इंटू 3 by 3 पर होगा. So A point से 2 3 by 3, then from A to section 3 it is x3. So the distance between this half into 3 into 40 and section plane 3 3, it must be x3 minus 2 into 3 by 3. The another load is 80, and the distance of 80 is at 4.5 distance पर है A से C के बीच में, and from C to section plane obviously it will be x3 minus 4.5. So here I am writing x3 minus 4.5. Okay, so this is the bending moment equation. Clear? Now this is valid from C to D. So at C, x3 equals to 4.5 meters. So please put the value. At D, x3 equals to 6 meters, I hope. Is it? Yeah, 4.5 for C and for D it is 6 meters. रखें जरा वैल्यू, निकाल के बताएं. Please, quickly. Please find out. For point C, put x3 equal to 4.5, and for point D, put x3 equal to 6 in the above equation. And what you are getting, my dear friends, you will be getting it as 97.5 kilonewton meter. And how much at D by putting x3 equal to 6, how much you are getting? I hope you are getting minus 30 kilonewton मीटर. प्लीज सॉल्व करें, साथ साथ सॉल्व नहीं करेंगे देन आपको पता नहीं चलेगा कि यू आर एबल टू राइट और नॉट. ओके, सो अप टू सेक्शन 3 इज इट ओके? नाउ आई एम टेकिंग द सेक्शन 4. ओके, थोड़ा सा जल्दी करते हैं सो दैट आई विल बी एबल टू फिनिश द क्वेश्चन विद इन टाइम. ओके, x4 द इक्वेशन बहुत इजीली लिख सकते हैं. इजीली वी कैन राइट shear force at section 4. Now we are perfect. 55 minus half into 3 into 40 minus 80, and what else? The RD. This is also on the left side, and RD is how much? I hope it was 105. Yes, it is 105. Okay, sorry. Plus or minus? Plus. Why it is plus? The reason, on the left side of the section 4, it is on the left side, so upward. So the equation is like this. कहाँ से कहाँ तक valid है ये equation? From where to where? Okay, it is valid from left of D to just, from the right of D to just left of E. तो मैंने लिख दिया at D क्या आ जाएगा, जरा निकाल दें. x पर तो डिपेंड कर ही नहीं रहा, so it will be constant equation. So 55 minus half into 3 into 40 minus 80, ये आ गया था minus 85 and plus 105 और हो गया, so it is coming out plus 20 kilonewton. And at point E also it is coming out plus 20 kilonewton. Okay, is it okay? इक्वेशन जल्दी कर दी, सेम टाइप की इक्वेशन बार बार लिख रहे थे. ओके, नाउ आई एम कमिंग टू दी बेंडिंग मोमेंट इक्वेशन एट सेक्शन 4. ये भी हमारे लिए सिमिलर, सॉरी ओके, 55 माइनस हाफ इंटू 3 इंटू, oh sorry, no, we have to write the bending moment equation. We have to write what? Bending moment, and I am writing the shear force equation. Let me correct it. Okay, no issue. Okay, so it is 55 into x4 minus half into 3 into 40. This is the load, and the distance of load from section plane is x4 minus 2 into 3 by 3 minus 80 into x4 minus 4.5 plus 105 into x4 minus 6. Please check. 55 into x4. 55 की distance कितनी है? It is x4. 55 x4. This is half into 3 into 40. It is at x4 minus 2 into 3 by 3 distance. 80 kilonewton. 4.5 यहाँ से यहाँ तक है. So from 80 to section 4, it is x4 minus 4.5. 105 is at 6 meters. So it is the distance यहाँ से यहाँ तक कितना होगा? x4 minus 6. So that's what I have written. And it is valid from where to where? It is valid from D to E. यहाँ भी D से E तक निकाला था ना? From D to E. So at point D, what is x4? For point D, it is 6 meters. And for point E, x4 equals to 7.5 meters. So please put, इन दोनों को रखिए please. जरा रखें, x4 equals to 6 meters, x4 equals to 7.5 meter, यही है ना? 6 for D, for E it is 7.5. क्या आ रहा है भाई? If I am putting here, I must say it is MD equals to minus 30 kilonewton meter, and at point E it is coming out 0. Please check. मैंने तो रख दिया. According to me, these are the right answers. Okay. सारे sections हो गए. Now let me draw the shear force and bending moment diagram. So that space I am utilizing for drawing the shear force diagram. Okay. Please check the equation. How is this equation? First equation. This is x1 square. So parabolic equation for shear force, and values क्या हैं? A पर 55, B पर -5. So at point A it is 55, at point B it is -5. और ये सॉरी कैसे ज्वाइन होंगे ये दोनों वैल्यूज? बाय अ पैराबोलिक कर्व. बाय अ पैराबोलिक कर्व. कैसा पैराबोला होगा ये? एक्स स्क्वायर वाला. इज इट ओके? देन अभी शियर फोर्स ड्रॉ कर रहे हैं. सेकेंड इक्वेशन ऑफ शियर फोर्स. Second equation of shear force, constant line equation, -5 to -5 from point B से C तक. Okay, so from B to C, constant. Okay, at point C we are having two values. One is for the left side, another one is for the right side. So on the right side it is -85. So -85. So these are the two values. And then C to D section 3, again equation कैसी है? Constant line की. It is the constant line equation. So C और D दोनों जगह -85 है. So -85. At point D also, because of the point load, because of the support reaction, we are getting two values of shear force. One is at the left side, which is -85, and another one is on the right side of the point D, which is +20. So +20. Then from D to E, +20. So this is 55 kilonewton. This is -5 kilonewton. This is 85 kilonewton, and this is 20 kilonewton. This is positive, this is negative, negative, negative. So this is the shear force diagram. सजा दिया बिल्कुल completely. Okay, now I am coming to the bending moment. Bending moment. Okay, bending moment equation check कर लेते हैं. Bending moment कैसी equation है? Cubic. Bending moment equation cubic, and at point A it is 0, at point B it is 105. At point A it is 0, at point A it is 0, and at point B it is 105. और इन दोनों के बीच में what we are observing, that in the section plane 1 there is a point where shear force is 0 and F equal to dm over dx, saying what? wherever the shear force is 0, the bending moment either will be maximum or minimum. So जो क्यूबिक कर्व ड्रॉ करेंगे वो थोड़ा केयरफुली ड्रॉ करेंगे ऐसे. मैक्सिमम कहां दिखना चाहिए? मैक्सिमम मस्ट बी जस्ट बिलो द पॉइंट वेयर शियर फोर्स इज 0. ओके, क्लियर? सो दिस इज द, और ये कर्व कैसा होगा? क्यूबिक. दिस कर्व इज क्यूबिक. नाउ आई एम कमिंग टू द इक्वेशन ऑफ सेक्शन 2. कैसी है भाई ये इक्वेशन? स्ट्रेट, ओ इंक्लाइंड लाइन इक्वेशन, y इक्वल टू mx प्लस c के फॉर्म में, नथिंग एल्स. एंड द वैल्यूज आर b पर 105 एंड एट पॉइंट c इट इज 97.5. तो कैसे ड्रॉ होगा ये? इंक्लाइंड लाइन से. ज्वाइन कर दिया इंक्लाइंड लाइन से. ओके, देन आई एम कमिंग टू द सेक्शन 3 इक्वेशन. इट इज अगेन द इक्वेशन ऑफ इंक्लाइंड लाइन. देखिए कहीं एक्स स्क्वायर आ रहा है क्या? नो, देयर इज नो एक्स स्क्वायर. सो अगेन, और वैल्यूज क्या हैं? व्हाट आर द वैल्यूज? 97.5 फॉर C and for point D it is -30. So let me draw -30 here. Inclined line equation. Then section 4 equation is how much? कैसा है? Again inclined line equation, and at point E it is 0, at point D it is -30. Draw हो गया. This is 105 kilonewton meter. Sorry, this is 97.5 and this is 30. लिख नहीं रहा मैं, वहां पर बहुत स्पेस नहीं है. ओके ओके, बट इट इज स्टिल नॉट कंप्लीटेड. इट इज स्टिल नॉट कंप्लीटेड. अभी एक नंबर का काम और बचा है. यदि आपने इतना क्वेश्चन कर दिया, आप कहेंगे सर इतना सारा कर दिया, बट अभी भी क्या बचा हुआ है? यस, देयर आर 2 पॉइंट्स आर हियर. 1, ये पॉइंट मैंने बोला कि जहां पर शियर फोर्स 0 है, वेयर द बेंडिंग मोमेंट विल बी मैक्सिमम. एंड एक पॉइंट ये है यहां पर वेयर द बेंडिंग मोमेंट इज चेंजिंग इट्स नेचर. बेंडिंग मोमेंट नेचर चेंज कर रहा है, पॉजिटिव टू नेगेटिव इट इज गोइंग. So this is the point which is point of contraflexure and this is the point where bending moment is maximum. कैसे निकालेंगे भाई? कैसे निकालेंगे? For finding out this, observe करें कहां आ रहा है ये? सेक्शन 1 में. सेक्शन 1 में shear force 0 कहां होगा? कैसे निकालेंगे? By putting this equation of shear force at section 1 equals to 0. जब इसको 0 रखेंगे, किस इक्वेशन को? Again I am repeating the thing. For finding out the point of maximum bending moment, the shear force is 0. shear force section 1 की इक्वेशन में 0 हो रहा है. सेक्शन 1 के लिए shear force की इक्वेशन ये है. Put this equation 0 and you will be finding out x1 equals to how much? I have already calculated, so I am writing here 2.87 meters. अब क्या करूं मैं? बेंडिंग मोमेंट की इक्वेशन विच इज फॉर सेक्शन 1, पुट x1 इक्वल टू 2.87 एंड यू विल बी फाइंडिंग आउट दिस वैल्यू विच इज द मैक्सिमम बेंडिंग मोमेंट एंड कैलकुलेट करेंगे आप. सो इट इज कमिंग आउट हाउ मच? इट इज कमिंग आउट 105.31. चेक कर लेना. ओके, आई एम राइटिंग हियर, बहुत छोटा सा, सॉरी नहीं लिख पा रहा वहां पर. ओहो, कोई नो वरीज, लिख लें उसे. 105.31 at 2.87. This is the maximum value of bending moment. Now I am coming to the point of contraflexure where bending moment is changing its direction, changing its nature from sagging to hogging. And ये कहां पर मिला हमें? This point I am getting between C to D and C to D is the area for section 3. और यहां पर क्या 0 हो रहा है mathematically? We are finding that the bending moment is 0. Bending moment is 0. So bending moment is 0. सेक्शन 3 के लिए this is the equation. इस इक्वेशन को 0 कर दीजिए. इस इक्वेशन को 0 करें, you will be finding out the value of x3. किस इक्वेशन को? For finding out the point of contraflexure. भाई सेक्शन 3 क्यों? Because C से D के ही बीच में मुझे ये पॉइंट मिला. तो C से D के बीच में पॉइंट मिला, तो इसको आप 0 करें. 0 करेंगे so you will be getting x3. आप लोग तो कैलकुलेट करेंगे नहीं या करेंगे? If you people are doing, then very good. Otherwise x3 I have already calculated. It is coming out 5.41 meters. चेक कर लीजिएगा, मे बी कैलकुलेशन एरर कहीं हो गई हो तो आप मुझे बता देंगे, बट अकॉर्डिंग टू मी. तो अब ये क्वेश्चन 10 मार्क्स के लिए कंप्लीट हो गया. ओके, दिस क्वेश्चन इज नाउ कंप्लीट फॉर 10 मार्क्स। सपोर्ट रिएक्शन निकालिए, सेक्शंस डालिए, इक्वेशंस लिखिए, डिफरेंट डिफरेंट पॉइंट्स के लिए shear force एंड बेंडिंग मोमेंट की वैल्यूज निकालिए। हाउ इज द नेचर ऑफ कर्व, अकॉर्डिंग टू दैट ड्रॉ द shear force and bending moment diagram. If you are finding at any place the shear force is getting 0, so obviously at that point the bending moment either will be maximum or minimum. यहां पर दोनों ही है, at this point it is maximum और यहां पर भी तो shear force 0 हो रहा है, so it is minimum, -30 it is coming out. Okay, so this is the point. Then if you are getting any point in the bending moment diagram where bending moment is 0, so that point is point of contraflexure. इतना काम यदि आप करते हैं then you are eligible for 10 on 10 marks. Okay, so if it is clear up to this point, I hope कि I tried my level best to complete the question. 4 sections लिए, lengthy question था, some calculations I already did so that I can save my time. I hope कुछ calculation. अब कुछ बच्चों को there are some students those who feel very मतलब tough sometimes कि how to write the equation. Otherwise proper way is this, write proper equations and proper equations को solve करें, because from that you are getting the nature of shear force and bending moment diagram. But if not possible, then there is one shortcut method also, and that shortcut method is known as direct method. So I am concluding my, but I will not suggest anyone. I am saying on camera, I am saying I am not suggesting, because this is not the right way, this is only the shortcut to check the solution. But if anyone is not comfortable, then he or she can go with this type of method. So what is the type of beam? The beam is available here. Okay, for that shear force and bending moment diagram we can draw. Okay, लोड दिख रहा है मुझे, बीम है कैसा, ओवरहैंगिंग टाइप का बीम है, यूडीएल है, यूबीएल है, ओ और क्या है, पॉइंट लोड्स हैं, डिस्टेंसेस आर शोन। क्लियर, इतनी बात क्लियर है। क्या क्या मुझे मालूम होना चाहिए बिफोर दिस, बिफोर गोइंग फॉर दिस टाइप ऑफ डायरेक्ट मेथड? वी मस्ट नो कि यदि यूडीएल होगा तो shear force डायग्राम इंक्लाइंड लाइन होगा, बेंडिंग मोमेंट डायग्राम पैराबोलिक कर्व होगा, पॉइंट लोड होंगे तो वहां पर shear force डायग्राम कांस्टेंट लाइन होगा, बेंडिंग मोमेंट डायग्राम इंक्लाइंड लाइन होगा। दीज इंफॉर्मेशन मस्ट बी अवेलेबल विद अस, ये हमें पहले से मालूम होना चाहिए, otherwise we will not be able to solve the question. Okay, now I am coming to the calculation part. I am not wasting much time. So first step is to find out the support reaction. Support reactions निकाल दिए गए, RE is coming out 55 and RB is coming out 45. RE कहाँ है, यहाँ पर है, RB 45. Okay, one more thing in this question you will observe, it is not necessary कि जो साइन कन्वेंशन हमने लिए हैं वही साइन कन्वेंशन ही वैलिड है कि ऑन द लेफ्ट साइड ऑफ द सेक्शन प्लेन अपवर्ड shear force will be considered as positive. कोई इसके अपोजिट ले सकता था कि लेफ्ट साइड में अपवर्ड को मैं नेगेटिव ले लूं, क्या फर्क आएगा? द ओनली डिफरेंस विल बी द shear force diagram will be constructed in the mirror image of our convention. Okay, so ये क्वेश्चन में इन्होंने उसी तरीके से किया हुआ है, तो मैं आपका कोई डाउट ना रह जाए, that's why I am taking this. So RE and RB calculated, then shear force calculation. Let me start from point F. Let me start from point F. Let me start from point G. G point पर there is no load, so shear force is 0. So between G to F, shear force will remain 0. At point F, we are having what? We are having 40 kilonewton downward, 40 kilonewton downward. We are moving from the right side. साइन कन्वेंशन जो हमारे हैं, हमारे जो बेसिकली साइन कन्वेंशन यूज किए हैं उससे बिल्कुल अपोजिट हैं, सो मिरर इमेज विल बी देयर. सो ऑन द राइट साइड से मूव किए, डाउनवर्ड है -40. नाउ आई एम कमिंग टू द पॉइंट ई. तो ई पॉइंट पर और ई के राइट साइड में जितने भी फोर्सेज हैं सभी का सम ले लेते हैं. ई के राइट साइड में क्या क्या फोर्सेज हैं भाई? ई के राइट साइड में 40 है और ई पर 55 है, सो इट इज कमिंग आउट V इक्वल टू 15 किलोन्यूटन. देन at point D, what will be the shear force? -40 plus 55, and at point D, how much it is? -50. So how much it will be? -40 -50 -90, and -90 और E point पर था ये कितना? So it is coming out 35. Calculation D and D के right side में whatever the forces are there, all the forces, algebraic sum of all the forces. Then at point B, shear force will be the forces on the right side minus 40 plus RE minus 50 plus RB. It is coming out plus 10. Okay. Then from point B to A पर भी calculate कर सकते थे. Yes, we can calculate up to A also. So A minus 40 plus RE minus 55 plus RB, and how much it is? UDL 20 into 0.5. So I hope it is coming out 0. It is coming out 0. Similarly, we can calculate the bending moment also. Bending moment from the right side we are moving. So G to F, there is no load, so no bending moment, no moment. Okay, force is 0, so force 0 है तो moment भी 0 ही होना है. Then at point F, so ये दोनों 0 लिखे हुए. At point E, what is the force? 40 kilonewton. How far it is from point E? 0.5, so 40 into 0.5. Then I am coming to the point D, 40 into 2, 40 into 2, tendency of rotation is clockwise, and RE into 1.5. RE into 1.5, so it is coming out 2.5. At point C, what are the forces? 40 into 2 plus 2, 4. Okay, at point C, 40 into 4, RE into 3.5, 50 into 2 on the right side. Then at point C we are finding out one point moment, so definitely we will be getting two values of bending moment here. One is on the right side and another one is on the left side. So minus 62.5 to 100, ये add हो जाएगा उसमें. So at point B, then at point B how much will be the bending moment? That we can find out. So this is the shortcut method. Now shortcut method के साथ साथ, now do you get any information? Are you getting any information here? कि what will be the shape of bending moment? What will be the shape of shear force diagram? No. So this must be known to us. पहले ही मैंने बोला था कि ये हमें मालूम होना चाहिए. But anyways, यदि मैं equation नहीं लिख पा रहा, if I am not able to write the equation, then this can be the. So the solution is, complete solution is available here, but still I will not suggest this method to be adopted by any student. यदि बिल्कुल भी नहीं लिख पा रहे हैं, then only you can go with this particular type of method, otherwise no. So here I am ending my chapter shear force and bending moment. In the description you will find the details or the playlist of my previous videos related to this topic. Go through all these. Definitely I am very sure you will be able to do the question with the section method itself completely, correctly. No doubt, I don't have. So thank you very much for watching this. Thank you.